All right, so what is the difference between a nuclear reaction and a chemical reaction? Well, primarily it deals with the different subatomic particles, or the big difference between the two is what subatomic particle is involved in the reaction. Chemical reactions are only involve electrons. So the electrons are involved in chemical reactions. They can be gained or lost, and they can be shared. Chemical bonds are essentially shared electrons or transferred electrons. And so if in a change the electrons are involved in that change, it is of course a chemical reaction. Nuclear reactions, on the other hand, involve protons and neutrons. Of course, the subatomic particles in the nucleus, hence nuclear reactions. Involve changes to the number of protons and or neutrons in the nucleus of the atom. The energy regimes between these two types of reactions are very, very different. Chemical reactions are everyday reactions that you're used to. The most energetic, of course, would probably be combustion reactions. Nuclear reactions are what fuel the sun and stars and are responsible for, unfortunately, nuclear weapons. So they are a very different energy regime. They're in a very different energy regime, nuclear reactions are. But that's primarily what we're going to talk about in these videos. Okay, a couple of terms that we're going to need to identify before we get started talking about nuclear reactions are the terms radioactive, radiation, and nuclide. Radioactive. If something is radioactive, it is an atom with an unstable isotope. Excuse me, an unstable nucleus. Since it is unstable, eventually it's going to do something that creates a more stable nucleus or more stable system. When a radioactive substance reacts, it will emit radiation. And radiation is the particle or energy emitted during a nuclear reaction. And since we're going to be talking about reactions quite a bit, most of the time, or some of the time, I will abbreviate reaction as RXM. Now, what is a nuclide? A nuclide is essentially a way that we can talk about a specific isotope. So maybe I want to talk about a carbon-14 atom. One way I could talk about that specific type of isotope, one with 6 protons and 8 neutrons, would say the carbon-14 nuclide, versus, let's say, the oxygen-18 nuclide. So, what are the types of particles and energy that can be emitted during a nuclear reaction? Well, there's 4 main types that we're going to discuss. They are alpha particles, beta particles, positrons, and gamma rays. Each type of particle or energy has a couple set of symbols. Most of them have a couple set of symbols that we can use. All four of these types of radiation or energy have Greek letter symbols and then atomic symbols that we would use for nuclear equations. The alpha particle, we use the Greek letter alpha, which looks like that. And its atomic symbol, well, it turns out that an alpha particle is essentially a helium nucleus. So a helium nucleus contains 2 protons. So we would put that in the left subscript. And 2 neutrons, so to give it a mass number of 4. The mass number is going to be important for eventually balancing nuclear equations. And then, of course, the charge will impact a lot of physical properties of the particles as well. So the next one is the beta particle. And the beta particle, of course, we're going to use the Greek letter beta, which looks like that. Oftentimes we will put a negative superscript right there for the symbol because it is very similar to the positron and we want to differentiate the two. The beta particle is essentially an electron that's been emitted from the nucleus of a radioactive isotope. And so for the atomic symbol, we're going to use E, a -1 for its atomic number, which will help us, again, balance nuclear equations. And then since it doesn't contain any protons or neutrons, it has a mass number of 0 and a -1 charge. A positron is the antimatter of the electron. So it's an electron with a positive charge. And so its atomic symbol would be +1. Still has no no protons or neutrons. So we'll give it a 0 for its atomic symbol. And we use the beta particle, or the Greek letter beta, for its symbol. And specifically, we absolutely need to put the positive sign for its charge to note that it is not the electron, it is a positron. It also has a mass number of 0 since it has no protons or neutrons, and the charge is +1. Gamma rays are electromagnetic radiation, and so that's where the energy term came in our definition for radiation. We're going to use the Greek letter gamma for its symbol. And since it is only a particle of light, a photon, we really have no atomic symbol numbers for it. 0 and 0 for it. It does not have a charge, it's light, and it does not have any protons or neutrons, so it has a mass number of 0. Of course, the different types of radioactive substances are emitted through nuclear reactions, and there are actually 2 types of nuclear reactions. There are nuclear fission reactions and nuclear fusion reactions. If you think about the 2 names, we might be able to come up with the definitions of them. A nuclear fission, think fissure, is when a radioactive isotope or nuclide breaks down or decays into smaller nuclides and of course emits some type of radiation. A nuclear fusion reaction is sort of the opposite. Think fusion, think fuse. It is a nuclear reaction involving forcing 2 lighter nuclides together to produce a new, heavier nuclide.